You know what is standard deviation and its importance. There are 4 ways to find standard deviation of data. I will discuss each of these in detail in this video. Before going into that, I want to explain you what is grouped data and ungrouped data. Data obtained in raw form is ungrouped data. This is also called as raw data. Whereas grouped data is in more condensed form. Groups of suitable size is made and frequency is mentioned along with group. Let's deal with ungrouped data first. As I told you, there are 4 ways to find standard deviation. They are direct method, actual mean method, assumed mean method, step deviation method. Let me explain you about direct method. Let me repeat the definition of standard deviation. It is the square root of the average of the squared deviations from the arithmetic mean. In direct method, we just stick to this definition. That first we will find the arithmetic mean, then we will find the deviation, and then we find the squared deviations, and then we find the average of squared deviations. Square root of average of that squared deviations is nothing but standard deviation. Let me explain you in detail. Let x1, x2, x3, so on up to xn be the given scores of data and x bar be their mean. Deviations from the mean would be x1 minus x bar, x2 minus x bar, x3 minus x bar, so on xn minus x bar. Let's find the square of these deviations. It is x1 minus x bar square, x2 minus x bar square, x3 minus x bar square, and xn minus x bar square. Sum of the deviations is sum of x minus x bar. Average of squared deviation is sum of x minus x bar square by n, where n is the number of scores in the given data. So, variance or sigma square is equal to sum of x minus x bar square divided by n. Standard deviation is nothing but square root of this variance. Hence, sigma is equal to square root of sum of x minus x bar square by n. X minus x bar square is x square minus 2x into x bar plus x bar square. Hence, sigma is equal to square root of sum of x square minus 2x x bar plus x bar square divided by n. We can arrange this as sigma is equal to square root of sum of x square by n minus sum of 2 into x bar by n plus sum of x bar square by n. Sum of x by n is nothing but the mean, which can be represented as x bar. Hence, it is sigma is equal to square root of sum of x square by n minus 2 into x bar plus sum of x bar square by n. We know that sum of x bar square is nothing but x bar square until n times. It is basically n into x bar square. Hence, we can write this equation as sigma equal to square root of sum of x square by n minus 2x bar square, because x bar into x bar is x bar square. And we are writing sum of x bar square as n into x bar square. It is plus n into x bar square by n. Cancel the term n. We get square root of sum of x square by n minus 2x bar square plus x bar square. Minus 2x bar square plus x bar square is minus x bar square. It is sigma is equal to square root of sum of x square by n minus x bar square. we are writing x bar as sum of x by n again. So it is square root of sum of x square by n minus sum of x by n whole square. So finally we have arrived at the equation. Sigma or standard deviation is equal to square root of sum of x square by n minus it is sum of x by n whole square. This is the formula we use in direct method to calculate standard deviation. Notice we need sum of squares of scores, sum of scores and number of elements in scores in the data. Let's find standard deviation using this method. The number of samplings planted by 8 students during a year are 2, 6, 12, 5, 9, 10, 7, 4. Calculate the standard deviation for the data. In order to find the standard deviation using direct method, we need sum of squares of scores. Hence, prepare a table. Write the scores and squares of scores. This is the table. Let's call scores as x. Hence, square of scores is x square. Arrange scores in ascending order. The scores are 2, 4, 5, 6, 7, 9, 10 and 12. Respective squares are 4, 16, 25, 36, 49, 81, 100 and 144. Let's find sum of scores, that is sum of x. Addition of 2, 4, 5, 6, 7, 9, 10 and 12 is 55. Let's find sum of squares of scores. Addition of 4, 16, 25, 36, 49, 81, 100 and 144 is 455. And notice the number of scores in the given data is 8. Hence, n is equal to 8. Now we have the data of n, sum of scores and sum of squares of scores as well. N is equal to 8, sum of x is 55, sum of x square is 455. Recall the formula to find the standard deviation. It is sigma is equal to square root of sum of x square by n minus sum of x by n whole square. Substitute the values. It is square root of 455 by 8 minus 55 by 8 square. 55 by 8 is 6.88. 455 by 8 is 56.88. It is square root of 56.88 minus 6.88 square. 6.88 square is 47.33. So, square root of 56.88 minus 47.33 is square root of 9.55, which is 3.09. On an average, each score deviates from the mean by 3.09. This is nothing but the standard deviation. We found the value of standard deviation using direct method. Well, there are some limitations with this method. We cannot use this method if data is huge. As it involves squaring each score, this method is not useful if data has non-integers. This method works well with small set of data and scores are integers. Let's study one more way to find standard deviation. This is called as actual mean method. Let me explain you steps involved in this method. First step is finding the actual mean. That is finding the actual arithmetic mean of all the scores in the data. Second step is find the deviation of each score x from actual mean. If d is the deviation, then d is equal to x minus x bar, where x bar is the actual mean. Third step is square the deviations. Find d square. Fourth step is find the sum of squared deviations, that is sum of d square. Fifth step is find the average of squared deviations. This is nothing but the variance. It is sum of d square by n, where n is the number of scores in given data. Sixth and final step is find the square root of the average of squared deviations. It is square root of sum of d square by n. Have a look of all the steps involved in actual mean method. Let me explain this to you with an example so that you get better clarity. The number of children born in 10 different hospitals during a month are 9, 12, 15, 18, 20, 22, 23, 24, 26 and 31. Calculate the standard deviation. Prepare the table. You have to list all the scores, respective deviation from the mean and square of each of deviation of scores. Before preparing this table, let me calculate the mean. Add all the scores. Addition of 9, 12, 15, 18, 20, 22, 23, 24, 26, 31 is 200. 200 by 10 is 20. So, 20 is the mean of this data. In order to find the deviation from the mean, subtract score with this mean. Let me prepare the table. This is x. Deviation d, which is x minus x bar. Square of deviation, d square. The given scores are 9, 12, 15, 18, 20, 22, 23, 24, 26 and 31. Let me find deviation of each of the score. Since 20 is the mean, deviation of 9 is 9 minus 20, which is minus 11. Deviation of 12 is 12 minus 20, which is minus 8. Deviation of 15 is 15 minus 20, which is minus 5. Like this, deviation of 18 is 18 minus 20, minus 2. 20 minus 20 is 0. 22 minus 20 is 2. 23 minus 20 is 3. 24 minus 20 is 4. 26 minus 20 is 6. 31 minus 20 is 11. Now we have deviation of each of the scores of given data. Let's find square of deviation d square. Minus 11 square is 121. Minus 8 square is 64. Minus 5 square is 25. Minus 2 square is 4. 0 square is 0. 2 square is 4. 3 square is 9. 4 square is 16. 6 square is 36. 11 square is 121. Now find sum of these d squares. Sum of all these elements is 400. Sum of d square is 400. We have value of sum of d square. Recall the formula. Sigma is equal to square root of sum of d square by n. Substitute the values. Sigma is equal to square root of 400 by 10. 400 by 10 is 40 and hence it is square root of 40. Square root of 40 is 6.32. So, value of standard deviation of the given data is 6.32. Now, we know two methods, direct method and actual mean method. Let me explain you one more method to calculate standard deviation, which is called as assumed mean method. This method is pretty similar to actual mean method, but difference is we don't use actual mean, but we assume a random score in given data as mean and then we proceed. Let me list you the steps involved in assumed mean method. First step is assume a score as mean. Call this as A. Find the deviation of each score from the assumed mean. Since we assumed A as a mean in given scores, deviation D is x minus A. Square of deviations. It is D square or x minus A square. Find the sum of squared deviations. Sum of D square. Find the sum of deviation. Use the formula. Sigma is equal to square root of sum of D square by n minus sum of b by n whole square. Substitute the values of sum of d square and sum of d is the 7th step. 8th step is calculate standard deviation sigma. I hope these steps are clear to you, but let me solve an example so that you get better idea. The number of sick people who were treated as outpatients in hospital on each day during a week are given below: 50, 56, 59, 60, 63, 67, 68. Calculate the standard deviation. In order to calculate standard deviation, using assumed mean method, we have to assume a score as mean. Let's say we assume 60 as mean. Let's find the deviation of each score from this assumed mean. Then square of deviation. Let me prepare a table. This is X, list of all the scores. This is D, deviation from assumed mean, which is X minus A, D square. Given scores are 50, 56, 59, 60, 63, 67 and 68. You have list of all the scores. Since we assume 60 as mean, find the difference of each of scores and mean. For first score it is minus 10 because 50 minus 60 is minus 10. 56 minus 60 is minus 4. 59 minus 60 is minus 1. 60 minus 60 is 0. 63 minus 60 is 3. 67 minus 60 is 7. 68 minus 60 is 8. Now we have list of deviations from assumed mean. Let's find squares of these deviations. Square of minus 10 is 100. Square of minus 4 is 16. Square of minus 1 is 1. Square of 0 is 0. Square of 3 is 9. Square of 7 is 49. Square of 8 is 64. Find sum of all these squares. It is 239. Also find sum of these deviations. It is 3. Now we have all needed values. The formula we are supposed to use is sigma is equal to square root of sum of d square by n minus sum of d by n square. Substitute the values. It is square root of 239 by 7 minus 3 by 7 square. 239 by 7 is 34.14. 3 by 7 square is 0.18. So it is square root of 34.14 minus 0.18. It is square root of 33.96. Sigma is equal to square root of 33.96, which is 5.83. The last method we are going to study is called as step deviation method. This method is very much similar to assumed mean method. As in assumed mean method, we assume a random score as mean. But there is a small change in this method. This method involves finding the common factor of all the scores. Let me write all the steps. First step is to assume a score as the mean. Second step is to find the difference of each score and assumed mean. It is X minus A. Third step is to identify the common factor of the scores. Let's call this as C. Fourth step is to divide the difference by common factor. That is D is equal to X minus A by C. Fifth step is square the deviations. It is D square. Sixth step is to find the sum of squared deviations. Sum of D square. Seventh step is to use the formula and find the standard deviation. Formula we are using is sigma is equal to square root of sum of d square by n minus sum of b by n square into c. This formula is similar to the formula which we used in assumed mean method, but we are multiplying it with common factor C. Let me solve an example. The number of books issued in a school library during the first 10 days of month are as follows: 20, 30, 40, 60, 80, 90, 110, 120, 130, 140. Calculate the standard deviation. First and foremost thing you should do in this step is to identify the common factor of all the scores. From the scores, it is pretty clear that common factor is 10. Prepare the table and list all the scores. Assume a score as mean. I will assume 90 as mean. Second column lists all the deviations from this assumed mean. For example, 20 minus 90 is minus 70. 30 minus 90 is minus 60. You can see all the deviations from assumed mean. Once we calculated this, we should divide each of these by common factor. Let's call this common factor as C. So, the third column is x minus a by c. So, minus 70 by 10 is minus 7. Minus 60 by 10 is minus 6. Minus 50 by 10 is minus 5. Minus 30 by 10 is minus 3. Minus 10 by 10 is minus 1. Like this, we divide all the deviations by common factor and list them in third column. Now, find square of these numbers. Square of minus 7 is 49. Minus 6 square is 36. Minus 5 square is 25. Square of minus 3 is 9. Like this, I have listed squares of each of the deviations. Now, find sum of deviations. Sum of all these elements is minus 8. Now, find sum of squared deviations. It is sum of d square, which is 174. Formula we are supposed to use is sigma is equal to square root of sum of d square by n minus sum of d by n square into c. Substitute the values. It is square root of 174 by 10 minus in the bracket minus 8 by 10 square into 10. It is square root of 17.4 minus 0.64 into 10. It is 40.9. So, standard deviation of given data is 40.9. Until now, we studied the methods of calculating standard deviation using direct method, actual mean method, assumed mean method and step deviation method. Now, let's try to find the standard deviation of grouped data. In this part of video, we will learn how to find standard deviation of grouped data. As I explained you earlier, grouped data is a way to represent large set of data. Here, we group scores of some range and provides the frequency. While calculating the mean, in order to find the sum of scores, we multiply the score or midpoint of class interval with frequency, that is fx. Formula for calculating the standard deviations in grouped data is sigma is equal to square root of sum of ft square by n minus in the bracket sum of ft by n bracket complete square into c. Ft is multiplication of deviation and frequency of each group. Check video in practice session where I have solved problems related to finding standard deviation for grouped data.